All right, let's get right into it. Today, we're not just talking about some incremental update to an AI model. We're going to dive deep into the science behind a new model, DeepSeek-R1, and how it's being taught to actually reason, to solve complex problems from scratch, instead of just mimicking patterns it's seen a million times before. And that really gets to the heart of the matter, doesn't it? This is the central question, the big challenge that AI developers are wrestling with right now. How do you make that jump from an AI that's an incredible copycat to one that's a genuine problem solver? So here's our game plan for this explainer. First, we're going to tackle the core issue with the old way of teaching AI to reason. Then we'll look at the new approach, and this is the good part, see if the numbers actually back it up. We'll peek under the hood at how it works, be honest about where it fails, and wrap up with a pretty radical new rule for thinking about AI. Okay, first up, let's talk about the big roadblock. You'd think the best way to teach an AI how to reason through a problem is to just show it a perfect step-by-step solution, right? Well, it turns out that's not really how it works. In fact, it can be a huge problem. Think about it like this. Imagine you're a student in a classroom. The old method, supervised fine-tuning, or SFT, is like the teacher showing you exactly how to solve a problem on the board, and your goal is to memorize those exact steps. You learn to replicate. But reinforcement learning, RL, is totally different. It's like the teacher says, look, I don't care how you get there, just get me the right final answer. One teaches you to copy, the other teaches you to actually solve the problem. And that's the key takeaway here. The old method was basically training AI to be really good actors. They got amazing at writing out explanations that looked like a human was reasoning through something. But the system was rewarding the performance, how good the explanation looked, not the actual result. And that's a world of difference. All right, so if that's the problem, what's the solution? Well, this is where DeepSeek-R1 completely flips the script. The whole idea is to shift the focus away from the process and put it squarely on the destination, the final, correct, and, most importantly, verifiable answer. And this quote just nails it. It's the core belief behind this whole project. It's such a simple but powerful idea, right? If you want an AI that's good at reasoning, you have to reward it for getting the right answer, not just for sounding like it knows what it's doing. Okay, that all sounds great in theory, but where's the proof? Does this new method actually deliver the goods? This is where we stop talking and start looking at the cold, hard data. Let's see how this thing actually performs on some seriously tough challenges. And whoa, the results? Well, they speak for themselves. On 𝗍𝗻𝗄, which is a really high-level math competition, it passes almost 80% of the time, on its very first try. On a standard math benchmark, it's hitting over 97% accuracy, and in competitive coding, it's performing at an expert level. You know, these aren't subjective tests. These are about getting objective, verifiable answers right. I mean, let's just sit with that number for a second. 97.3%. On a really tough math test, a number like that isn't just a small improvement. It signals a real breakthrough. It's proof that focusing on the final answer actually works. And that pass at one metric we just saw is a really big deal. Here's why. It means the model got the answer right on its first attempt. No do-overs. This isn't about the AI getting lucky after 10 tries. It's about reliable, first-shot problem solving. That, right there, is the true test of a reasoning engine. So we've seen that it works, but how does it work? Let's pop the hood and take a look at the engine that's making all of this happen. We're going to walk through the reinforcement learning pipeline that powers this whole thing. It's actually a pretty simple and elegant loop. First, the model gets a problem. Then it tries to solve it. An automated verifier then checks only the final answer. If it's right, the model gets a point, a reward of 1. If it's wrong, it gets a 0. And based on that simple feedback, it updates its own internal strategy. It's like a little digital thumbs up or thumbs down that teaches the AI which paths are more likely to lead to success. And I know I keep saying this, but it is the absolute magic of this whole system. The model gets 0 credit for a beautiful, elegant, well-written solution if the final answer is wrong, but it gets full credit for a messy, weird, roundabout process if the final answer is right. It is pure, ruthless outcome optimization. Now, you might be wondering, how do you keep this process from going off the rails? Well, that's where the secret sauce comes in. It's a technique called GRPO.
Instead of having the AI generate just one answer, which might be a lucky guess, it has it generate a whole group of different answers to the same problem. Then it compares them to see which approaches tend to work best. It's a much smarter way to learn, giving it a more stable signal of what's actually working.
Of course, no system is perfect. And one of the things that's really cool about the research here is how open they are about the limitations. So let's be honest and take a look at where this powerful reasoning engine starts to break down.
So the first and biggest weak spot probably won't surprise you. If a task doesn't have one single objectively right answer, things like writing a poem or analyzing a movie, this whole system just falls apart. And the reason is simple. If you can't give a clear 1 for correct and 0 for incorrect, there's no reward signal. And without a reward signal, there's no learning. Now, this next one is kind of weird, but it makes perfect sense. If you train a model only on getting the right answer, it can start to get, lazy about how it presents that answer. The outputs can become a total mess, unreadable, weird formatting, even mixing languages, because it's not being graded on neatness. The fix? You have to mix in a little bit of that old SFT method just to keep its language skills sharp. And finally, we get to the classic sci-fi problem. The AI can learn to cheat the system. It's called reward hacking. If there's any tiny flaw or loophole in how the answers are checked, you can bet the AI will find a way to exploit it to get that reward without actually doing the hard work. It's a fundamental challenge for any system based on reinforcement learning. So, after all that, what's the big takeaway here? What does this mean for the future? Well, it suggests we need to completely shift our thinking about what intelligence in these models really is, and more importantly, how we can actually build it. This quote right here is the mic drop moment of this whole thing. For so long, we've been trying to ask our AIs to reason, to just write a better prompt. But this research basically proves that's the wrong approach. Reasoning isn't something you can just ask for. It's a behavior you have to reward. You get what you incentivize, plain and simple.
And that leaves us with one final huge question to chew on. We've seen an incredible new way to teach AI to solve problems that have clear, objective, black and white answers. But most of our world, our ethics, our art, our decisions, isn't black and white. It's all shades of gray. So if the most powerful form of AI reasoning we have only works for objective problems, what does that mean for its ability to help us navigate our messy, complicated, and very subjective world?